Okay, so this is Lab 3, part 3 of airspace measurements. So basically, we're simulating a flat plate at 10-degree angle on a wind tunnel. So first, we set up the geometry.
Everyone's seeing.
So this is the geometry which I made. We'll import it from SolidWorks into Ansys, right? And then you import it, make sure everything looks all right. Then after you're done with that, come to the mesh. Takes a while to load. Takes a long time to load. Okay. Yeah, so once the mesh is up, so basically what I did, I went here to mesh and I added a space sizing over the face. Right? I made the element size very small, so when the mesh comes out and you render it, it'll be a lot of detail. So when you simulate it, you get accurate results. And we want to add extra meshes around the object of interest to make sure the information and not information, the data we acquire is most accurate here, which is our point of interest. Data padding and edge sizing around the object and putting 150 subdivisions on it to make sure we're accurate. And then we just uh, generated mesh. This is the result we got. Then you gotta name selections of basically what the objects are. So you want to label the inlet, you want to label the outlet, the walls of the wind tunnel, and label your object. So later, when you're going to simulate it, if you know what to simulate over or which part to simulate about, right? So once you finish that, you come to the yeah, here you go. You come here to the setup, and you want double precision, make sure it's accurate, make sure it's 2D because that's what we're doing, 2D simulations. Right? So once it's loaded, you can see your model here. You wanna go to materials, fluid, air. You make sure these quantities are correct and accurate onto it. Actually, so make sure it's the proper properties of air. Then you want to go into your boundary conditions. Make sure you go inlet, right? And since for this case we're doing 60 hertz, the equal velocity magnitude for 60 hertz on the wind tunnel will be this 4.3358 meters per second. So this is what we want to put in here to make sure we simulate the flow at the 60 hertz, right? So once you finish that, just put in your number, click apply, close it out, right? Get that done. Also, if you wanna just triple make sure little models, little viscous, since we're doing a viscous simulation, you'll make sure that you are doing viscous, right? So sure your viscous model is right. We're using K epsilon because of its, it's accurate. It's a good model to use. That's what for viscous model. Okay, so just might make sure that okay. Then next part is to get your lift and drag coefficients. We're gonna go to for definitions, right? I already have it made, right? But essentially you wanna click new, and when you click new, you see a page like this, right? Anyway, okay, so you want to click the drag coefficient, you type the name up here, right? And you want to set over the angle flat plate, which you defined earlier, as it's the area basically around the flat plate, which is what we care about, right? So once you name it, make sure it's the drag coefficient that you're getting. Just click OK. Do the same thing for drag force. Same thing. Make sure it's over the angle flat plate. Click OK. Make sure this is drag force. Do the same thing for lift coefficient and lift force. So once all done, you come over here, the initialization. I'm using hybrid. You can also use standard. For now, I'm using hybrid. What you want to do is click initialize. Sure. Which is gonna automatically set up like the boundaries for you, and like when you get the data, it's gonna automatically size the graphs for you, which is nice and neat. Also automatically sets up the initial speed to be the inlet speed, which it's important since that's what we're simulating at, which is 60 hertz. So once it's done, you can come here, uh, run the calculations, right? Just click and click calculate. It'll take a bit. So this will take a bit, especially depending on how many polygons you have in your mesh. The more long it's gonna take, it's your more calculations. Right, so once you're done, you can come here, you can see the space information. So here we can see the graph of our drag force, which makes sense, right? Initial iteration have a high drag and then quickly balanced out to a constant drag force. Same thing for a lift force. You get some noise in the beginning and some bandwidth until you stabilize towards the end. And here you have your drag coefficient and also your lift force, which is same story. Some noise in the beginning. As the regions go on, it balances itself out by its most common coefficient, right? So that's the results, and you can also come here and see the static pressure, and just you can see changes in envelops the mesh. Also do the same. If it doesn't pop up like this, you can just come back down here, go to graphics, contours, and go to just contour two. In this case, would be basic click and display. You show the view the velocity magnitudes on the whole wind tunnel. You can see the wake region back here, the area of high pressure down here, and the area of low pressure on the top, which is increase your lift force. So yeah, that's pretty much the Lab 3, part 3 of the lab simulation of a flat plate on a 10-degree angle on a wind tunnel. Thank you. Oops.